Hello, everybody. My name is Piotr. I work at Halborn. Full suite. We offer full suite of services, security services for blockchain companies. And what I'd like to show you today is, what I'd like to talk about today is, well, lessons learned from, well, Solana program audits that we did at Halborn. So let me see. Okay, so I have some background in IT, so you know, like Web3 cybersecurity is like one of the recent things I've taken up. What I'm going to show is what we've seen, you know, what you guys are building, you know, what is the security impact of all your work. So let's just start with, I'm going to show you like a bunch of charts, and you know, just please remember, like, this is data you guys created. I'm just showing it to you. So like, you created those slides. I'm just presenting them. So starting with like the, I suppose, most important metric of them all. So just looking at this chart, we can immediately tell that one of like, we see like there's on average there's like about 8 vulnerabilities, 8 findings in every project, and like 1 of 5 is really like critical or high. So the severity is you know, is very high in this case. So like 8 up to 10. So you can see there's a sum of likelihood. This is our metric how we measure severity. So likelihood 1 to 5. 5 is like most likely, and then impact 1 to 5. Again, 5 is like the most devastating impact. So we can see like, you know, from 8 to 10. So like really bad issues, bad vulnerabilities. It's just 1 in every 5. So this is something concerning, I think. And then looking at the another chart is so we can see what's the ratio between users and protocol in terms of the affected party. So so it does seem like users are impacted way more often than protocols. Again, if a protocol is impacted, then users are usually impacted as well. But in general, users are like way more vulnerable to attacks than protocol vaults or config parameters. Just looking at types of impact we've noticed, so what we can see that almost 1 in 10 issues is loss of funds. Now that's obviously like the most devastating thing that can happen to a protocol, losing, you know, their users' funds or the protocol funds. Then we can see that, you know, we have like, if you look at the issues here, like for example, denial of service, that's a Web 2 problem. So you might think that it's not applicable to Web 3, but it is. It's not that common, but it's still there. Same thing goes for loss of privileged access and you know, some other types of vulnerabilities like susceptibles, which means it may happen, but not necessarily. Going forward, now we can see why those vulnerabilities pop up in the programs you guys develop. So we can see that you know, like one of the most prevalent causes here is sanity check missing, and the sanity check, it's just usually one if statement. So one if statement is something that, you know, prevents bad actors from accessing your protocol funds, and you know, like it's almost 20%. Again, it's almost 1 in 5. Next, we have edge case is not handled. Again, it's a really simple if statement checking, you know, if a value does not exceed like you know, something you guys can expect. And then we have poor business process design. So meaning the logic that was implemented could have been implemented, you know, in a more robust or, you know, better way. And again, it's like 15%. So it's as we can see in the at the other issues, it's still quite common. which is interesting because like in traditional web security, usually insufficient input sanitization, so basically input validation is the #1 cause of vulnerabilities, whereas in Web3, it's like somewhere in the middle, which paints a really nice picture how different root causes of vulnerabilities in Web3 are to Web2. And just looking at the critical vulnerabilities, so obviously, like the most often we see like almost 3 out of 4 critical vulnerabilities are about loss of funds. So there are different types of fund loss vulnerabilities. So one obvious one is draining user of protocol vaults, but also stealing and bypassing fees. And something that might not be that obvious is rent stealing, meaning closing accounts on behalf without proper authorization and in consequence losing the rent. Then we have loss of privileged access, meaning you guys just lose control over config accounts, over the entire protocol. And users in turn may also lose access over their own accounts. Incorrect processing results, that's a sort of a consequence of poor business process design, meaning like, for example, a mathematical formula was implemented incorrectly, or there's like a step in business logic that can be bypassed in certain circumstances. We have also denial of service in just 7% of cases, meaning your users cannot access, they cannot interact with your programs. So this is quite critical because it threatens the entire business model. Now looking at root causes, now we can see this is pretty evenly distributed here. So insufficient input sanitization, somewhat similar to Web2, is the most common cause. So we have 36%, so more than 1 in 3 root causes is exactly insufficient input sanitization. We have poor business process design, so again, implementation issues, insufficient access control, the famous signer check missing, or more generic identity check missing. And we have sanity check missing, so just one if statement that should check that a ratio should be lower than 100%. That's missing, and that's why fees are charged way over what it should be. Now to something even more interesting, we're going to have a look how Anchor framework improves, or how Anchor framework affects program security. So I imagine right now most of you, if you're building with Anchor. So you might think that because it's a framework, it implicitly makes your project more secure. So let's have a look if that's exactly the case. So looking at vulnerability severity, so how many issues that we found were critical or high. So it's not a copy-paste. Those charts are very much similar. So looking at that, especially those most critical issues, so the highest severity, we can see that those values are pretty comparable. Again, this might mean there might be an issue in sort of understanding how you can utilize the framework in your protocols. When we look at the sort of lower severity issues, then again, they are pretty much the same. I guess the key takeaway from here is, regardless if you develop a native Solana without any frameworks, or you develop with Anchor, there's the chance you're going to make a mistake and someone may exploit it, or an auditor is going to catch it. Well, it's pretty much the same. Now, looking at what issues are most common. So obviously we have low quality of service, and that's a very broad term. So low quality of service means for example, generic error messages, or missing on-ramps, or just sort of very complex instruction data sets. that make it a bit awkward for users to interact with. So then that may in turn means there's a loss of revenue, or some other projects may not be willing to work with your project because interacting with it is it's not fun. It's not the user experience is something that could be improved on. We have also corrupted data, and we can see that it happens more often with Anchor programs than with native programs. A corrupted data, meaning you end up saving state that is pretty much invalid. Then we have increased operational cost. Now this covers like two categories, because we have protocol operational cost and we also have client or user operational cost. So if you have increased user operational cost, that means users pay more fees, transaction fees, for using your protocol, because the implementation is suboptimal. Whereas if there is a protocol increased operational cost, that means you might have implemented some dead code. There may be some tautology expressions. There could be some redundant state variables, which means it's more expensive for you to deploy the program. And if you want to upgrade it, it's going to cost you more too. Looking at loss of funds, we can see that it happens twice as often in Anchor programs compared to native programs. Loss of privileged access, it's more of a problem in native Solana. Low CI/CD rating, that's something that comes from the Web 2 world, and that means you guys might be using components with known vulnerabilities, outdated packages, crates. So if someone were to plug your project as a dependency, so in a CI/CD pipeline, the score would be appropriately lower. Loss of privileged access, again, more of a problem in native programs. Same goes for denial of service. Missed revenue increase opportunity. So, for example, you give a chance or you give the possibility to users to, for example, set fees to a value that's too low. So your protocol earns less from user interactions. Ineffective business process, that might be kind of cryptic, but pretty much what it means is you implemented a feature that does nothing. And it might sound, like something that doesn't happen, but it actually does. And we also have loss of rewards. So this is quite different to loss of funds, because funds are, something that someone entrusted to your project, and if they lose it, they lose something that entrusted to you. However, loss of rewards, that's something optional. It's like a yield farm that you can get some tokens from it. But if you lose those tokens, you technically don't lose your funds. You just lose the rewards. So it's not. It is critical. I definitely agree, but it's not as critical as losing your capital. So looking again at root causes, we can see how Anchor abstracting away most or many of low-level operations help sort of mitigate the feature not implemented root cause. It's almost twice as almost like half as common as in native programs, because obviously in native Solana, in edge case you have to implement your own serialization format. Anchor does it for you, so feature not implemented is not that much of an issue. However, insufficient input sanitization. Now you might think Anchor does so many things for you, it's virtually impossible to accept invalid input, but it seems like it actually is. And compared to native Solana, it happens a bit more often. Could be because you have to implement so many things when you develop the native Solana that you do it sort of automatically. Again, insufficient access control is more of a problem in native programs because Anchor does a lot of that for you. Business process design, it's pretty much comparable. Sanity check missing happens a bit more often in Anchor programs. Edge case not handled, again, happens more often in native programs. Again, probably because Anchor does so many things for you. However, if you've ever run cargo expand on an Anchor program, you'll see a lot of code. So that means there may be some redundant state or transmission data required by Anchor program. Best practice is not followed. Well, it's kind of natural. It happens more often in native programs because best practices are somewhat automatically implemented by Anchor. Missing documentation, so that's what that means is error messages are not verbose enough, or in general documentation is lacking some quality, or error messages are misleading or too generic. It's a bit more often in Anchor programs, but still it's a very low value anyway. And components with no vulnerabilities, that's pretty much the same in both. Now, looking at root causes for loss of funds vulnerabilities. So this is something that happens in almost half the Anchor programs that we've audited. So insufficient input sanitization. So even though you have all the constraints, all the conditions you can implement with Anchor attributes, still you could do better with input sanitization. However, access control is a bit more of a problem in native Solana programs. Same goes for poor business process design. However, sanity checks and edge cases, that's a problem in Anchor program, albeit it's not that common. So I guess key takeaway in native Solana programs, what you really need to pay attention to is just doing that signer check and just looking at your business process implementation if you did handle all the cases, even those you did not think of initially, just having tunnel vision or on the happy path. So you might think, what could be common issues in Anchor? I mean, it does so many things for me, and there are two which basically boil down to one thing. So we have those two properties of Anchor context, and one is remaining accounts. So remaining accounts, with Anchor programs, you basically know what accounts you expect, so you define the context, but you might have some, some business logic edge cases where some account might be optional, and that's where it goes. It goes to the remaining account slice. And what's important is what we can see here. This is account info. Account info is like bare bones Solana account metadata. So that means all Anchor security checks are not applied to a remaining account. So if you do use remaining accounts, please remember to do the signer check, do ownership check, please try and avoid type confusion. So all the 5 common Solana vulnerabilities, they can apply to remaining accounts. And same goes for unchecked accounts. Now, the name is quite verbose, but it still happens that unchecked accounts remain unchecked in the code. Unchecked account means basically you don't know, in Anchor you cannot specify the type of the account because you don't know it, or there are no Anchor types for that account. So if there are none, if that's the case, and you do have to use unchecked accounts, please check them. Because all those 5 common Solana vulnerabilities apply to unchecked accounts too. And just looking at how the findings that we reported were addressed. So looking at there's some bad data here, but we can see that in general, findings are fixed. 1 of 3 is acknowledged, meaning it's not a feature, it's not a bug, it's a feature, or you're just accepting the risk. And just 1% of findings are pending patches, meaning a program was deployed but the vulnerability was not fixed, and it's pending. It's going to be fixed in a future release. And getting to the last slide, so breaking down, finding status by severity, like we can see that 100% of critical findings are fixed, so no loss of funds, no loss of privileged access in deployed programs. Almost every high finding is also fixed, just a very small part is acknowledged. Now, what I guess we all can see a pattern here. So as severity decreases, so does decrease the ratio of fixed to not fixed in general issues. So we can see that with medium, it's 3 out of 4 they're fixed. With low, it's 50-50, and informational is also pretty much just as low. So that's all I had for you today. Hope you guys enjoyed it. Hope it was informational. Thanks so much for your time, and see you around. Thank you.